Hello viewers, let us look at this question. We are asked to calculate the enthalpy change in this reaction given the bond energy below. Okay, this is the bond, the parameter for the bond energy, and this is enthalpy change for each of the parameter in the bond energy. So when you are asked to find the calculate enthalpy in bond energy, you are going to use this formula. Enthalpy change is equals to bond broken minus bond form. This is the formula you are going to use for what? For bond broken. What are the bonds that are being broken down? We have 18 here broken down to what? To 18. You get that? If you want, okay, we have fish here. This is how this one is being expressed. Hydrogen bond is what? You get that? This one is expressed like why this one is expressed as this, how this one is what expressed. Okay, so we are going to look at isolate. We are going to isolate this one, and for use it for our calculation. Now watch out. Now what we are going to do is that look at the parameters here. The first thing we're going to do is that for the this is the reactor, and this is what the product. That is bond broken is this one, while bond form is what is this one. So what you are going to do is that for reactant you have reactant. For reactant we have CC. The first thing you are seeing here is what? CC. Look at CC. You get that? For CC, what is the parameter given? 615 is equals to what? 615. Now, the next thing you are seeing is what? CH. Look at CH. C is bounded with what? H. CH. What is given? We have CH is equals to what? We have 414. Now count the number of H that are bounded to C. We have 1, 2, 3, 4. Okay, so here we have what? 4 CH, because any value here we are going to multiply it by the number given. Is that understood? So now the next thing in the reactant we have what? HH. So we have HH is equals to HH is given as what? 435. Is that understood? The next thing, we are done with the reactant. Let's proceed to the products. In the product, the first thing we have here is product. The first thing we have here is what? CC. You got that? We have CC. That is C single bond. All right, single bond. We have what? CC is equals to what? We have 3, 4, 7. The next thing we have what? We have CH. Have you seen? C carrying what? Hydrogen atom. CH. CH is equals to what? What is our CH? We have 414. You get that? But how many hydrogen atoms are being carried by the CH? We have 1, 2, 3, 4, 5, 6. 6 hydrogen atoms. We have what? 6. Is that understood? So you are going to look at both the product and the reactant. The one that are similar, you cancel. All right. So here CC is not similar with C double bond here. This one, so this one is free. Now go to CH. CH here, and we have what? CH here. So it's similar. So we have what CH here is what? 6, and CH here is what? 4. So we are going to minus 6 by what? By 4. So if we minus 6 by 4, we have what? 2. So here we'll be left with what? 2, and here there will not be left with anything. So we'll rule this one out. That one is completely out. What you are going to do is that you're going to add this one, add the one of the bond broken, and add the one of the product form, that is the bond form. Then you now minus it and you have your answer. Is that understood? So let's continue. So this one now you are going to add this one and this one. So we say 61550. That is for what? For the reactor. Now let's proceed for this one. Remember this one has what? Has 2. So you are going to multiply this one 2 first. So we say 2 times 414, which will give us what? 8. Do you get that? Of course, remember to. Now the next thing you are going to do is that add this one. Of course, we have 4, 7 plus 8, 2, 8. What you are going to have is what? 5. Do you get that? So now 1175. Remember, bond broken. This is the one of bond broken. That is a product. That is a reactant. And this is the what? The one of what? Bond form. So Kj. Okay, so now substitute into our formula. So we have 1050 minus 1175. So we'll give you what? Minus 125. So the enthalpy change now. Enthalpy change now is Kj per what? Per mole. So this is our final answer in this problem that is being asked. All right. So now just know that when enthalpy change is negative like this, it is exothermic reaction. Exothermic reaction means that heat is being released into the environment. Do you get that? In every chemical reaction, it is either heat is being released or heat is being absorbed. Okay. When heat is being released, it means that it is exothermic. When heat is being absorbed, it is what? Endothermic. So for more of this video, please subscribe to Ojemai YouTube channel, or you can as well follow us on Facebook on Ojemai Online Chemistry. Do well to like this video, share, and comment. Thank you.